everyone. Bismillah ar-Rahman ar-Rahim. Hello everyone. This is Bakir Mohammed from Algeria with you, the writer of the resonance energy device explained, published in Patrick Kelly website. This is another video to demonstrate a new way to work with the extended Tesla bipolar wall. It's a new way, and I tested this, and it gave a good result. Even I have to work toward the resonance because I am still using this kind of circuit. As you see here, you have high voltage flyback transformer DC pulse. Okay, you have a high voltage DC from this side, and you have capacitor. After the capacitor reach the breakdown voltage for the spark gate, the current will flow in this circuit like this, because this will be positive and this negative. The spark gate have to be in the negative side, not in the positive side. Okay, because if you put the spark gate in the positive side, the current will be low. So the ETBC have to take the positive charge, okay, and this means the current, most of the current will enter L1. L1 is the reactor coil or the source of power. Anytime you manage this coil better, you see L2 secondary coil will push more power to the capacitor bank. But in this video I will not talk about L2. I will talk only about L1, because the most problem in this circuit from this side, all the problem. But this side will only conserve the power, and after that it's easy to convert the power into alternating current to the desired voltage and frequency. Okay, I think this is easy, but at this moment we are using toroidal. Okay, the reason for using the toroidal core is to conserve all the magnetic field in the core. Okay, if all the power circle around the core, it's easy to take it from L2, not like air core system. In air core system, it's difficult to tune, and we will discuss this in this video. Okay, you see the core I am using now. Recently I published in Energetic Forum a way to use the extended Tesla bipolar coil with the TV yoke or any core you have. But the problem in this design, it's the way we wind our coil. You see now the first turn. This is our bipolar coil. This is our bifilar wall are wound on this toroidal, and finally you have something like that. But if you remember the concept of extended Tesla bifilar wall, it must be wound not around the core like this, but it must be wound on the same place. We don't need to move like this. But this design is not easy to work with because the power obtained will be very low. This is why I am using a high inductance in L1 wall like this. I am trying in this design to produce a high inductance, but any bifilar arrangement will provide a low inductance, so it's not easy at all to produce a good amount of inductance with bifilar system. So recently I find a good way to bypass this problem and produce a good amount of power. Not only that, but the new design will open the door for new improvement, because this design can be updated or increased to the amount you want. Let's see how this design work step by step. At the first, we have to use L0. Okay, L1 now is composed from two sides. L0 please the ETBC. Okay, let's do it like this. ETBC. Okay, L0 is a large turn number wall wound in the ferrite core. Before you wind the ETBC, you start winding L0 and divide it to two identical parts. You see, if you see your design, there's 2 points are from here. You connect your high voltage from here, from there's 2 points. But let's discuss what will happen in this ferrite ring after using this new design L0 free plus the ETBC. First of all, L0 has two things to do in our system. The first thing L0 will do is to decrease the resonance frequency. Okay, in the case if you are able to achieve the resonance without using the spark gap in serial, so see this capacitor will be connected directly to L1, and maybe you can use the spark gap as voltage suppressor in this case, so any unwanted voltage may break the system here will be eliminated using the spark gap in parallel. This is another scenario, but let's start talking about the most easy scenario so we could understand what is happening. L0 will produce a good magnetic field around the circle. Okay, This is very important because anytime the ETBC see a good magnetic field, it will start to oscillate strongly, and it can produce a good amount of power. So the ETBC in the L0 in this case will do two things. The first is to produce a good amount of magnetic field, and the second thing is to lower the resonance frequency if in case you are able to achieve the resonance in this case. For example, if you let's talk honestly about the problem. The problem is the capacitor C. It's not easy to find a large high voltage capacitor. The most easy value to find and easy to build is maybe 20 nanofarad, okay, or 10 or 30, okay, but these values are easy to find and easy to build. Even if you don't find it, you can build it very easily. But in the case if the inductance is lower, it's a must to use a high value and high voltage capacitor. And this kind of capacitor can't be found easily. In most cases, you have to buy it, and they are very expensive. Okay, so the easy way is to increase the inductance of L1, and in turn we will decrease the value of C. For example, if we use Qual 32 program to see the resonance tank circuit, and if we know the inductance and the frequency, we could calculate very easily the external capacitor. If you have if the inductance is very high, for example 10 millihenry, and the frequency of your circuit, I mean the frequency coming from this side. If this frequency, for example 10 kilohertz, if this frequency is 10 kilohertz and the inductance is 10 millihenry, the external capacitor needed to achieve the resonance is 25 nanofarad, and this is very easy to find, and even tuning this device will be easy, not difficult. You can even lower the frequency, for example 7 kilohertz, and you see it's 51 nanofarad, and still relatively low capacitance. In the case you don't have this value, you can increase the inductance, for example 20 millihenry. You see we return to the previous value 25 nanofarad, and it's easy to find and easy to work with. Okay, this is the idea. The idea is to decrease the frequency from this side, so the tuning will be easy. You know, tuning in a lower frequency is easy. In other hand, we have to use back again to the video, and let's do a simple calculation. to know the impact of high inductance L0 coil on the magnetic power inside the toroidal. Okay, most of us know the famous equation of the inductance of the magnetic energy in any coil given by half L E square. This is the current. Okay. For example, if we have air core system, we may have, for example, some microhenry inductance. Take, for example, 10 microhenry. Okay. In the case if we use this technique, L0 will have high value given by millihenry. For example, 10 millihenry. Okay. If we convert millihenry to microhenry, we find 10,000 microhenry. If we divide this number by this number 10, we find the magnetic power can be thousands of times more in the toroidal arrangement. This is, I think this will be good in power production. Okay. Now, the new design. In this new design, we have to use also the extended Tesla bifilar wall in the original property. Okay. Now it's almost needed to close this junction. Okay, we don't need spark gap anymore in this side. Anytime you open this junction, you open the path for electric current, so you don't have the useful power. Okay, this side, the one dimensional capacitor have to be closed. Okay, let's see how the extended Tesla bifilar coil is wound in this design. But before this, let's see a working prototype. Okay, this is my latest prototype using 4 extended Tesla bifilar coil wound on the same place, like the original design as said before, and around the toroid. Okay, not like this, but in the same place. For example, take this place and you wind your ETBC. Okay, don't move here or like this. So you have to make the ETBC as the original design. In other hand, we need a little turn. We don't need 10 or 20 turn. I think it's better to work with 4 turn from 3 to 4, not more. Okay. So the extended Tesla bifilar coil will be near the magnetic core. Okay, if this is the magnetic core here, and you wind a 4 turn, you are sure the magnetic power is near this core. I think this is important. Okay, this is as I said, this is the new design. You have 4 qual, 1, 2, 3, 4, all the same qual. Okay, if you choose, for example, half meter long the ETBC wall each side, for example, this is the qual number 1. You have to choose the sum length. Okay, make sure all the ETBC work on the sum frequency. To do that, you have to choose the sum width and the sum length and the same material and the same insulator. Okay, the plastic insulator must be the same, the same tape, everything the same. So you have to build your ETBC identical. This is important to achieve identical ETBC. In this design, I am using 4 ETBC in this small TV yoke, and honestly, the work was very difficult because in small toroidal, it's not easy to work everything in this small toroidal. But this design, I didn't use the concept L0. I only used the ETBC as primary, and they connected in serial like the following design. Okay, in this case, I propose to you. I think it's better to use a lot of ETBC and to use a large toroidal core. For example, you can use 50 centimeter diameter. Okay, if this is easy. There is a way proposed by a friend to me. They proposed to work with the epoxy resin and mix it with a small part of ferrite, okay, to produce any desired core you want. I think this way is easy to breathe, but let's first talk about how to wind your ETBC around the core. Make sure to wind each ETBC on the same place. Okay, don't move anyway. Make sure to use a faux turn because a faux turn will give a higher frequency. For example, you can achieve megahertz of frequency in each ETBC very easily. Okay, if this is the number 1 ETBC, make sure they wound the same way as L0. For example, if we see this is the toroidal and this is our way how to wind the qual. Okay, in this case the qual is wound clockwise. Okay, you see it's clockwise. Imagine the current is flowing from this side, for example, and it's clockwise. Even if you see it from this side, because it's a solenoid coil, it will be the same direction from any side, from here or from here. Okay. Now, when you complete your L0 and divide it by two identical sides, start to wind your ETBC from this side. Okay, this is a simplified design just to show you how the ETBC is wound along the core. Okay, now if you have to wind the ETBC one from this position and ETBC 2 here, ETBC 3 here, 4 here, 5 here, 6, whatever the number you want. You can work with 10 ETBC or even 20 ETBC. Okay, but remember, the more ETBC you use, the more power you will have. Okay, and the power will be proportional with the square of the ETBC number you use. For example, in my case, I use it for ETBC. Okay, if someone use, for example, 10 and I am using 4, okay, the amount of power he have compared with the power I have personally, he will achieve 100 because it's the square of 10 and I will have 16. Okay, imagine you have 30 TBC. In this case, the power will be 900, more than a single ETBC. The square of 1 equal 1, and the square of 13 equal 30, equal 900. And this is a huge amount of power. If combined with the resonance, the power will be unbelievable. The reason for this huge amount of power obtained using this way is this: each ETBC produces a current in L2. Okay, this is L2 here, and this is the ETBC 1, for example, 2, 3, and finally 4. Okay, ETBC 1 will push E1 current. ETBC 2 will push E2 current, not in serial, but it will add another current to L2. ETBC 3 do the sum. ETBC 4 do the sum, and etc. if you have a lot of ETBC. In my case, I have only 3 ETBC and I have a small core, so the power is 16 times more than single ETBC, and this is proven practically. I tested this and it worked. The oscillation in the circuit don't stop immediately after you turn the power off. Even if you switch the power off and you have oscilloscope, you see the power remain. The oscillation will damp, but there is a very nice electromagnetic feedback inside this device. Keep the oscillation. What will happen in this case is a bit complicated because each ETBC will work with the next one and all work together to give a good amount of power. Even in the feedback will work very nice. For example, let's talk about the feedback Let's take another one. Let's talk about the feedback between each ETBC, how they work together. It's really amazing. For example, if you see this ETBC, it's, for example, 3 turn, and each one from this call are 3 turn. The induced voltage from number 1 to the 3 is they work as step up. It's a kind of transformer. If you see only this side from this side, you have a voltage step up. Okay, and if you see the 3 qual ETBC together, and they work as step down voltage toward this ETBC number 1, but the current is increased. Okay, it's very complicated to talk about how, for example, 4 ETBC work together. If the number of ETBC is high, for example 10 or 20, this phenomena will be amplified to very good amount of level. So I think good amplification will happen. If this is combined with the resonance, the result will be a very high amplification. Okay, let's talk how you wind your ETBC. First of all, as I said, start winding from this side. Okay, so you don't made mistake. It's better to start from this point and watch how the winding are there. I mean, if L0, for example, is wound clockwise like that, the current inside the ETBC have to follow the same way. About the connection, let's talk about the connection to make it easy. Okay, but before this, let's talk. You have the start point A and the end point B. Okay, and wind your ETBC. As I said, I am talking from this side, but practical, you have to start from here. Okay, and watch what I am telling to you now. In this case, B point have to be connected with A point of the second ETBC, and B point of the second ETBC have to be connected with the beginning of A point of the third, and etc. Okay, this is a kind of serial connection. This is look like the old design, the mixed extended Tesla bifilar wall, where we use two identical ETBC to work together. But in this design, all the ETBC are wound on some direction, and they work together the same working. I mean the frequency, they give the same amount of power, everything identical. First of all, you have to make your L0, and after that you have to cover your L0 with the sticky tape to isolate this L0 coil. Okay, in the case you have a high power, there is no arcing in this, so you don't damage your device. Okay, and start something along the toroid. Okay, now how the ETBC is wound. As I said, it have to be wound like this way. For example, if you see a point, okay, and this is the end of L0, and you connect it with the first ETBC. This is the end. You connect. Watch. You have to choose from where to start. For example, start from this point, and you see the current flowing along this half L0 and end at this position. From this position, you have to wind your ETBC in each side. Okay, but here when you connect this point from you connect this point. Let's choose another color so it will be clear. You have to connect this one with the start TBC number 1, number 2, number 3. They all connected in serial. Okay, for 1, 2, 3, 4, 5, 6. Okay, 1, 2, 3, 4, 5, and 6. Okay, this the last ETBC must be connected with this and here. Okay, and the current flow like this, and finally you are at this point. Okay, you start from here. You see at 0 clockwise, 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 and you connect this point with the first ETBC, and you watch your ETBC how it is wound. For example, like this, the current flow. You have to see your core and don't make a mistake in this. Okay, and you see, watch how the ETBC is connected, and you see the current is still clockwise. For example, if I see from this side and toroid is here, I see the ETBC is counterclockwise, not clockwise. Okay, so don't make a mistake in this case. You have to put it from this side. If L0 is here, for example, and you connect it, and you see the current is counterclockwise. Okay, and the same happened to L2 ETBC number 2. Here, this is ETBC number 2, ETBC number 3, number 4, number 5, and number 6. Okay, and this one is connected also the same like this design. BA, 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 and BA. Okay, and here this is A, and this is B, and this is A, and this is B. Okay, it's easy, it's not difficult, but only watch the flowing of electric current must be in the same direction. Okay, that's all about this. There is nothing special in this design. After that, you need to wind your L2. You see here, L2 is the black wire. This is L2, and because I have the small, I wind I want L2 like this because I don't have a lot of space. Okay, this is, for example, clockwise, and I want another wall counterclockwise to form my L2 wall. But this design is very bad in reality. Why? Because the two wall clockwise and counterclockwise form a kind of parasite capacitor. So each side of L2 must be one far from the other side. I mean by far, not like my design. It wasn't good. Okay, for example, in your case, if you have a big toroidal ferrite core, you have to divide it and you choose your, for example, this clockwise, you have to choose the other side. One more thing about this design, the fall, I think it's better to use thick fall, okay? Thin fall are not good because they are damaged very easily and they have a high resistance, okay? In the case of thick, they are mechanically stable and they are have low resistance, so a high Q resonance tank can be produced in this case because each ETBC in this case has its a parallel LC tank. Okay, even it's not like any ordinary parallel LC circuit, but it look like it. Okay, that's all. I hope to receive your question about this. Please do the best you can do and share your result because I find in the forum a little people follow me or talk, so it's good to tell what is in your mind. So maybe we will have a good solution. But this design really produces a huge amount of power. The next step is to move to a kind of resonance using this design. As I said before, if the inductance is high, the capacitance C will be low. Okay, and I think it will be easy to achieve the resonance. The resonance is good. Why? Because, for example, if you see this design here, okay, my design is limited by the distance of spark gap. I have to make the spark gap small to achieve a lot of discharge, okay, but the voltage across the spark gap is really small, so the current flow in L1 is very small. In the case of resonance, you can develop a very high voltage. No, sorry, this one. In the case of resonance, you can develop a very high voltage between the capacitor. Okay, so a huge reactive current can flow choose no, width. So a huge reactive current can flow in L1. And if the current is very huge, you absolutely need a high current diode in L2. This is why Donald Smith used heat sink in his commercial device, because the ETBC, when see the huge amount of current, it will produce a very strong magnetic field. Okay, and the oscillation, if we combine this situation with this new design, the current will be very large. So you absolutely need a high voltage, high current diode. In this case, if you don't have this kind of diode, you have to use serial diode. Okay. In the case, for example, you need 6,000 volt, and each diode can work with 1,000 volt. You have 6 diodes. Okay. For example, if each diode handles 3 ampere, and the power you need, for example, 60 ampere, you need 20 of them. Okay, 20 for 6, you have 120 diodes. This is very large amount of diode. But I think in this case, the amount of power will be very large. Maybe less. Okay, but let's do the job and let's success in this. And after that, we will find how to solve another problem. Okay, thank you very much for your watching.